bridge monitoring. James is going to give us an update on that.
Can I share my screen? Okay. So the North Shore access is really this piece of land in here. That's what I want to talk about. This piece of land is kind of landlocked in a sense where you have the railroad on the north side, the river on the south, the TFAS property here, and you know, a long way to nowhere on this side. And so really, like, you can imagine the concrete, steel girders, rebar, all that sort of stuff, and that the personnel that we have to get into this area. You know, there's a couple of different options that we've looked at, and want me to go through those different options. One option was to like build our own personal railroad crossing. Short story is the railroad said no thanks, they would not like that. Another option that we're pursuing right now is an option using the existing controlled access across the railroad track here. If any of you have been down in this area, there's some constraints as you zoom in here that they have, like not really bollards, but some concrete in the middle of the roadway so that you can't just turn and go wherever you want. That's for the railroad crossing arm so that people don't see the railroad and then go around it. So one option that we're looking at here is being able to drive like a 40-foot trailer, semi-truck, and turn, and then maybe go through the portion of the TFAS site. So there's some discussions that we're going to have with folks from the TFAS area next week. And then we've also talked to the railroad about, they have a 50-foot right-of-way off of the center line of their track. Is not, it's using like this 25 feet on the outside of that and build a road along adjacent to and parallel to the railroad until we get down to that site. So that's something that we're actively pursuing right now. You can imagine that there's quite the process with the railroad to make that happen, but in discussions with them, they seem pretty amicable on that.
It seems like for them, they are very concerned about fires next to the railroad. So something where we're removing vegetation, replacing it with lots of gravel.
Yeah,
they may find that to be in their benefit.
Very positive about that option. Now we will have to work through FHWA and some reevaluation that wasn't studied, just to reevaluate some impacts. We're multiple parties that we have to get the nod from to go back and then talk through with FHWA the full permission to do it.
And then is there no option of access by water?
So then that's the easy way is
there. Go back up to that intersection again for just a second. Okay, so coming across the railroad, one option is to do that loop that actually gets into the TFAS site, which means we would have to get approval to go do that, which we're looking at. The other option potentially is to get some kind of an agreement with that nursery and make a great big loop around that first building, and then come in and then kind of smooth out that turn a little bit and then go into that access road. Those are the kind of the two real options you've got there.
Yeah, and I think even going through the nursery, because what we've learned on we thought maybe we could make some modifications to those bollards, and the piece in the middle is what makes it a quiet zone, so the railroad doesn't have to blow their horns going through there. Any modification at all to it, even temporary, is not allowed. So even if we went through the nursery site, we probably would still have to impact the very beginning of TFAS site to make it a park. So we thought maybe we could make some temporary modifications where we could open it, put it back, and railroad said no. If you move it at all, you violate the noise requirement.
Okay.
So I'm a little confused about the railroad saying that because it's the FRA, the Federal Railroad Administration, that sets those rules. So wouldn't they be the people to talk to see if there are any processes to do temporary changes?
We could follow up with them. BNSF has to move it as well in order to know when they do and don't have to sound their whistles. So
Right.
we haven't taken it above that. We're just taking it to BNSF for discussions.
Right. My point is, it's really easy for them to say, "Oh, don't touch that. It took us a long time to get here, and boy, they're impossible to deal with." That doesn't mean that
It can't be done.
it can't be done. They're just giving you the easiest answer.
Well,
We can
and
do that.
we may have a better connection with FHWA at this point. If we
It's
are,
Federal Railroad Administration, FRA.
We're also counting on the railroad to let us use temporarily a piece of their right of way.
Right.
And so we definitely want to keep everybody on our good side.
I'm not trying to get her pissed. I'm saying that if we get them permission to do this, I'm sure they would.
Yeah.
I can't imagine having any problem. They're telling us what they're really telling us is they don't think that it would be a reasonable process to get permission.
Yeah.
So then the other option that we're looking at, and I say other, but in addition to this roadway access, is access from the water. And I can turn on, I think, this. So this is the water levels, and anything like up in this area is really shallow, so shallow that with the equipment that they had here, they couldn't actually get into this. We've gotten that information since then, but from about this area to the land, we're going to need some sort of substantial structure to be able to drive concrete trucks and move girders and all sorts of stuff like that in. And so we're looking at either a trestle with like pipe pile, 36-inch diameter pipe pile, and like 40-foot spans going along this way to get to land, or some sort of a rock causeway.
You know, we have a ton of photographs of that river bottom before the dam level was raised.
Yeah.
So our baseline is based on a trestle going down.
Yeah.
And so we've told Federal Highways that we can in fact build the bridge this way, but there's some options that you're looking at that could do the same thing at a much reduced cost.
Mm-hmm. So one of the things that's unique about this area is the water is shallow, and there's a large portion of this that has a really thin layer of mud in it, and then you're into that bedrock that we're talking about. So if we're going to be like driving a pile down and you only go through like 5 feet of mud and then you hit bedrock, the pile is not very strong. It's wobbly and wants to fall over. And so what we're going to end up having to do to actually drive pile is drill a hole that you then shove the pile into. And so that's called like a down the hole hammer. So there's a drill bit that goes inside there and pulverizes the rock. Water lifted out the pulverized pieces of rock, and then we got to deal with that. And so most of this trestle would have to be utilize a method like that.
And that's built into the current cost estimates.
Yeah, that's built into the current cost estimate. And so
the cost risk there that we may or may not have enough money for that.
Yeah, a variation of that is built into the cost estimate. Say that. And then the other option that I believe is a lot more cost effective is to do some sort of a rock causeway. And especially in a case like this where we're in very shallow water and we're into mud pretty quickly.
how far out are you coming, James? Is it right to where your subsurface?
So one of the things that we want to do when we get in here and do some geotechnical drilling is to put a couple of holes into this area too and see what we really got. But yeah, anything where they couldn't get, I think we're building either a trestle or a rock causeway somewhere out into this area.
So the idea with either one on the river side, down where your little hand is, you want to build some kind of an approach where you can take a concrete truck from the Oregon side, as an example, loaded across, offloaded on either a trestle or a causeway, and move it into position.
So at the end of the rock causeway or the end of the trestle, we're going to have I was thinking of a way to describe this, like a drawbridge you'd have to go over a moat almost. And so that the drawbridge would come and land on the barge that would be held there by the tugboat. You drive the trucks off. We'd need that on either side.
And the reason for that is even with that access road, the likelihood of being able to drive a fully loaded concrete truck down that road is probably iffy at best.
Yeah, it's pretty steep, very steep, and the girders are going to be enormous. 365 kips. So
Big.
It's a big one. Yeah. So it's really two issues that your team is looking at. One is how do you build in that shallow portion of the river? What do you build off of? And two, is there access that can provide access to that structure other than just having to ferry across the river? And those are all opportunities to try to cut the overall costs down.
Right.
James, don't we have, I thought we have plans for the original bridge. Wouldn't those show where they found rock or something that seemed like rock? So give us some idea of thickness of the sediments.
Yeah, that's why we think it's 5 feet deep, and
Okay.
then you're into rock.
Okay.
So the other thing, while you got the picture there, it's a good picture to show the drilling equipment for those couple of holes that you're going to do in the next month or so. You're going to lift them off the current bridge, drop them over the side, and then bring them up to the location.
So I'm going to tease Mike here a little bit. We like to gently lower things over the side.
Not drop.
But because we can't get in here and we don't have the access from the railroad yet, we don't have any trestle built or anything. Yeah, we're planning on setting up a boom truck on the bridge and then lowering in pieces of a small drill rig and assembling it down on the ground to do the boreholes.
That's the 2 borings we were just talking about moving potentially to go that other piece.
What about asking a railroad to deliver material for you?
We talked about that a little bit and ruled it out. The rail line in here is a single rail line, and they're hauling pretty long loads through about every 20 minutes. I think it might be possible to get a couple of loads in that way, but then you also have to get something to remove the material off of the.
We did ask them if we could use one of their cranes to fix it.
Would their cranes even be rated to pick up that
They
big up?
probably have some that's good.
But these things, I mean, for what we're going to do with this boom truck, we're thinking it's like 600 pounds.
No, I meant,
Yeah, I
you're
know.
talking about the big girders lifting them off. Of
No, not the big girders.
Not that
No.
far away. No.
So bridge monitoring?
So bridge monitoring, since I have this up, so we're not distracted, I'm gonna turn that off. There's a handful of different components of the bridge monitoring. One is there's some survey prisms and some tilt sensors that have already been installed on all of the piers where they need to be. There's also 2 total stations. So that's the actual piece of survey equipment that monitors the location. One of those is up on the Mount Adams Fruit Company, and another one is down in the SDS lumber yard. We have gotten power to those now. And then this week, the next 3 days, what we're going to be doing is first of all, we're going to be installing the weather station up on one of the towers there. That's what, as Kevin was talking about, the 5, 10, 15-minute closures are going to be for us to pull up with a truck, get the thing off and get it up on top. And then the tide sensors, we're going to install those. And then the other thing we're doing this week is making sure that we can there's an auto lock function. These prisms are 2 inches diameter, and you're trying to sight them in from something close to about a mile away. And so there's some auto lock function that we're working on. We talked about that earlier, but, and so we have somebody flying in, one of the Frontier people from Colorado is coming in to help us get that auto lock function set up. And then the big thing is getting it all to communicate and get data onto the server that's located here in this building. So hopefully by the end of this week, all that gets wrapped up.
When you say tidal, do you mean
Yeah.
the surface of the water, surface of the pool height?
Pool elevation, yeah, yeah. So all of that's going to tie in, and we'll have real-time data to see how the bridge moves in relationship to the wind, to the temperature, and the pool elevation.
Do you know at all what the pool elevation sensor looks like?
No, not yet, but
Soon
soon I'm going to hold one in my hands.
So if you remember, one of the reasons for doing this is to get better information on history of winds and temperature, basically for construction of the new bridge and lifting loads up and when you do that and so on. That's one thing to set a price. The other thing that we did when we did this was we were assuming we were going to do some kind of at the time, a pile program, test program. Now it's drilled shaft and piles for your trestles, and see if we're going to do anything adverse to the current bridge. But at some point in time, it'd be interesting to know if we're still going to do that and when we're going to do it. What's that program going to look like?
So that, yes, that's something that's going to start being discussed in the task force meetings this week. It's on the agenda to get an idea of what that's going to look like. Good.
Christy talked to us a little bit, but is there a update on the environmental?
Do you have anything on the environmental that you wanted to add?
I can add just some observations. I think I mentioned before, we were talking about the federal shutdown potentially. But regardless, what we're hoping is that we'll have two applications in, one to the US Coast Guard, which is in pursuit of the bridge permit. And interestingly, that's one of the first applications and one of the last permits that we will receive. So it's got the longest lead time. And also we'll be submitting specifically to the Army Corps of Engineers